Well, I'm back again, and this time we have a velocity time graph. Don't be fooled. Remember, this is why you have to look at those axes to figure out what the heck the graph is trying to tell us. And if you think this is a position graph, you are going to be dead wrong, because it's a velocity time graph and it tells completely different information. All right, we see a lot of different elements on this graph. We see flat lines, we see sloped lines, and that's going to end up changing the overall look of our position graph. Because essentially, wherever we see a sloped line, we're going to have curves. Okay? But the process is the same as it was last time with going from position to velocity. We still want to take the graph and we're still going to break it into chunks. So basically, everywhere the slope changes, we're going to break into a chunk. So here's our first little chunk at 4. We're going to come all the way down to 4. Just like that. Okay? Repeat the same thing every time it changes. Looks like we change again at 8 seconds. So I'm going to do the same thing at 8 seconds. Okay? Just to kind of match it up a little bit. All right. Okay. Same thing at 10 seconds. We've got another change, another slope change. Going to change it right there too. Okay. 14. 14. Hope you're not getting dizzy from me moving the paper so much, but I feel like I have to. All right. 16 seconds. Same thing. Okay. Hope y'all like the sound effects. That's about as high tech as I get. Okay, so we have got it broken up. All right, and this is where it gets a little trickier, because remember, when you're going down the ladder, remember the ladder we're talking about is those little columns that we made in notes. When you go down, like from position to velocity, you look at the slope. But we're going up. We're going from velocity to position. Okay, and it's a completely different beast. Instead of looking at the slope, what we're going to look at instead is the area. Okay, what do I mean? Well, if you look at all the little shapes I've made when I made those little hash marks right there, I've got a triangle, I've got a rectangle, triangle, flat line, we'll talk about that one, triangle, rectangle. Well, what we're going to do is find the area of each of those little chunks. Okay. So I kind of like to do this just because it makes it pretty. All right, we're going to put little hash marks there to kind of show you the different little pieces. Okay. 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 So now we can kind of see the shapes a little bit better. Okay. So we're going to start with this little triangle. Okay. Remembering the area of a triangle is 1/2 base times height. So my base is 4, so half of 4 times my height of 2. So half of 4 times 2 equals 4. Okay? It's this 4. Uh-oh, got to do my calisthenics. My light's turned off. Hammer time. Okay, still not working. Jumping jacks. Come on, lights, turn on. There we go. Got the blood pumping. We're ready to go now. All right. So 4. Okay. Here's how it works out. We're going to assume that we have started at 0 position. And then after 4 seconds, we moved 4. So we're going to start at 0 and go to 4. And I'm going to put another dot right there. Okay. Now, this is where it gets a little trickier. How I connect those dots is very important. Okay. What this is showing me is that my velocity increased over time. So I started out going 0 and ended up at 2 meters per second. So I am speeding up. My velocity is not constant. I'm not going the same speed for 4 seconds. So how do I show that? A non-constant velocity? If you said curve, give yourself a pat on the back, because that's exactly what's going to happen. We are going to do a curve. And this is a curve that has us speeding up in the positive direction because we are in the positive land of our graph. So here we go. Here's our curve. Wham, bam. There we go. That's a beautiful curve. Beautiful curve. Okay. Next section, we have a rectangle. Those are easy to do areas of. Let's see how wide a rectangle is. 1, 2, 3, 4. So 4 by 1, 2. 4 by 2. All right. If you got a calculator out, slap yourself. It's too easy. 4 by 2 is 8. So what we're going to do is we stopped at 4 and we're going to move up 8. So 4 plus 8 is 12. Okay? Now, once again, it's important how we connect the dots. This was a flat line. This means our velocity is constant. Okay? We are not going to speed up or slow down. We're going to have a constant velocity. And a constant velocity on a position graph is linear. Okay? So we're going to connect that as a linear line, just like that. Pretty. All right. Let's look at the next graph. Next little chunk here. All right. It's a triangle. 1/2 base times height. Our base is 2. Our height is 2. Half of 2 times 2. Put your calculator away and slap yourself if you got one. Half of 2 times 2 is 1 times 2, which is 2. Now, be careful. We are still in positive land of our graph, which means we are still moving in a positive direction. So do not go down 2. You're still going to go up 2. Okay. We went up 2. Okay. Now, how are we going to connect the dots? Well, we have two choices. It's either going to be linear or a curve. Okay. But since it's linear here, what this is telling us is our velocity started at 2 and ended at 0. That would be slowing down. So we need to show a good old sad curve that shows it slowing down. Right? Oh, poor little object, whatever you were. Okay. Now, for the next little bit, I like these because these are easy. We have 0 velocity. And what does it mean we have a 0 velocity? Drum roll. You're not moving. Okay, so we're not going to move for the next 4 seconds. So at 14 seconds, we have not moved. Okay, a flat line on our position time graph. Bada bing, bada boom. All right, flat. Now, here's where it gets a little trickier. Uh-oh, we are now in negative land of our graph, which means we're going to be moving in a negative direction, which means we're going to go back closer to 0 now. We're going to start heading this way, okay, because we're going backtracking, basically, is what we're doing. Okay, triangle. What's a triangle? 1/2. My base is 2. My height is, I've got to count. 1, 2, 3, 4. Half of 2 times 4. Half of 2 is 1. 1 times 4 is 4. Okay? So, at 16 seconds, okay, I'm going to put a dot. Now, where do I put my dot? Well, technically, I just caught this, but half of 2, that's my base, but my height is not 4. No, Mr. Smith, you got that one wrong. That is a negative 4, which makes this a negative 4. So it means I got to go down 4. So I'm at 14, and I got to go down to 10. And I see 10 is right here. Okay, right there. Now, how do I connect the dots? Well, this is linear, which means my velocity is changing. It's not a constant flat line. So I got to do this as a curve. So I started at 0, according to this graph, and I sped up to negative 4. Okay? So it's getting faster, but moving in the negative direction. So here's what it's going to look like. That kind of curve. Pretty. All right. Now, let's look at the last little chunk. This is an interesting chunk because this is a big chunk of the graph. What's our area going to be? 1, 2, 3, 4. 4 by 1, 2, 3, 4. 4 by 4. Woo! Not the pickup truck. rednecks. No, this is a 4x4. This is our area, and we got to be careful because I'm about to make the same mistake again. My width is 4, but my height is -4. So this becomes -16. Okay, so here's how it works out. On this graph, I started out at 10. After 20 seconds, I'm going to move down 16. So I got to go start at 10 and go down 16. So that's going to put me at -6. Way down there, if you can even see it. It's like, whoa, way down there. All right. So how we're going to do this? Well, it's a flat line, which is good. So that means we're going to have a nice, perfect, linear, smooth as silk transition right here. Ugh, that's kind of ugly. I wish I had a straight edge, but that's all right. That's good enough. So guess what, ladies and gentlemen? We have just converted that graph into a position graph. All right. Looks good to me. Looks good.